In this lesson, we're going to take a look at another application of vectors, possibly our last application. If you want to do more, take physics. That's really where you start applying vectors. Okay, we looked at force yesterday. Today's going to be about the idea of velocity. Okay, velocity is moving in a certain direction at a certain speed. So start with a nice one. They're all just examples today. We're just applying our vector addition ideas. A plane travels due north at an airspeed of 900 kilometers an hour. Encounters a wind blowing from the west at 80 kilometers an hour. What is the resultant velocity of the plane? So as soon as I see the words north, I'm thinking to myself, there's a compass. If the plane's going due north, so straight north, 900 kilometers an hour. It encounters a wind blowing, careful here, from the west. So from the west typically means towards the east. Now, when I do this, I like to start at 0, 0 also. I go to the center and say, here's my from the west. Okay. This is a nice one because these are right angles. This also gives us the opportunity to use the parallelogram method. The vector at the bottom, the wind, could be at the bottom, or it could be at the top. A plane could be in the middle there, or it could be right there. There's my parallelogram, or in this case, a rectangle. The resultant velocity will be from the center of the tails to the tips. That's what we're trying to figure out. It's our R. Again, this is a pretty nice one because it's dealing with right angles. It's a rectangle. So 80 to the bottom, I'm going to think to myself, hey, it's also up here. This is just a Pythagoras question. A squared plus b squared equals c squared. In other words, r is the square root of that number, whatever that happens to be. My r is, I got 903.55. That's my speed. Because we're talking about velocity, a direction as well. So the direction I'm going to figure out will be this one in between here. That's my angle. I'm going to use tan to do this because it's a right angle triangle. The tan is my opposite over my adjacent. There you're going to use inverses. I got 5.08 degrees. So to answer my question, the plane is flying at, our speed was 903.55 kilometers an hour at, or in a direction, it was not flying north anymore because the wind pushed it, so I'm going to say north and 5.08 towards the east. And that's how we do bearings. We start straight up at north and push ourselves towards the east. Okay, I'm going to try another one. One of my suggestions as we move our way forward is pause and try some of these yourself. Plane is head north, 30 east, at a speed of 800. Okay, there's my compass again. So it says north, 30 east. What that means is start at north and go towards the east by 30 degrees. In other words, you can end up with a plane that's going about there. That angle is 30 from north towards the east. And that plane was going 800 kilometers an hour. It encounters a wind blowing in the direction of. So it actually tells us which way it's going. Southeast. When it gives us southeast, it means specifically halfway between south and east. So if this was south and this was east, southeast would be right in the middle between them. Or in other words, there's a 45 degrees there. The wind was 75. Again, I can use this idea of the parallelogram or vector addition. I move the green one from the where they join tail to tail to join them tip to tail. That would be up here. Making my resultant from the tails to the tip. If you pause and look at this for a second, you have yourself a C pattern. So if I can figure out this angle in here, which I can, that's going to be 180 minus 30 minus 45. In other words, 105. I can also figure out the angle right here. C pattern adds up to 180. So there's your 75. There. Why is that handy? Well, now I have things that are across from each other. Right? I know that the 75 degrees is actually across from the R value. And I could then use AD across from the angle they're going to want later on. And I can find R using my cosine law. So to figure out the speed, I'm going to go with the cosine law first. I've got AD squared, so A squared plus, I'm sorry, B squared plus C squared minus 2 times B times C times the cos of the angle between them. We figured out that was 75. This is our speed. And don't forget we want to square root that number. And I got 783.94 speed. We're talking about velocities. We need direction. So I can also use my sine law, and this is our typical idea here. The sine of our angle goes with the speed across from it, and the sine of the angle I want, which is this one here in the corner, is across from the speed across from it. We're going to partially cross multiply, so bring the 80 up. It gives me sine theta. I want to know theta though, so I'm going to take the inverse of this big mess of stuff. Just let my calculator do that work for me. So I keep it as exact as possible. And I get 5.3 degrees. Okay, now that's the angle inside the diagram. So I got to answer my question. Resultant velocity of the plane. So the plane is flying at, what speed did we have? Speed was 783.94 kilometers an hour at our direction now. So the 5 isn't our direction, part of our direction. But if you remember, the plane was going north 30 east. This is where the plane was, right here, right? Now our plane is actually, let's change color so you can see it. Our plane was doing this. Now our plane's over here, a little bit more. So now our plane's going to be going north. That's initially that 30, but it's gone even further towards east, or if you will, north 35.3 east. Okay, I'm going to try another one here. Pause it, try it yourself, see what you can do. Our plane is head north 40 east. There's our compass direction again. So this time our plane is starting at north, but going 40 to the east. So I know the angle inside is 40. And its speed is 800 kilometers an hour. A west wind. So that's telling us the wind is blowing from the west. Causes it to travel north 45 east. So here's my west wind. And it means my plane ends up at north 45 east. So now it's over here. Which means that little tiny bit in there is only 5 degrees. Now obviously if you look at the diagram, the west wind, the green one, I could put it up at the top here. It's not quite drawn to scale, but let's call it that size. Okay. Find the resultant speed of the plane and the speed of the wind. So how can we do this when we only have one speed? Well, I need to find the wind speed. I need to find the resultant, which if I can't find those unless I know some angles. So let's think about our angles that we know. We know that from the north to the blue line is actually 45. That tells us that right here, which means this side also has to be 45. And if you stop and think about some things in here, that's 45, and then we add that little 5 in there. I guess it means that it's so hard to draw this. Color. That this angle right here has to be 50 degrees. I'll put it inside the diagram. 50. Why is that helpful? Well, here is our C pattern. If that's 50, that means this one has to be 130. And if I know in the diagram there was this little 5 and 130, I can figure out the remaining one. 180 minus 130 minus 5. Pretty sure that has to be 45 degrees. So if I have all the angles in one side, I can use the sine law to do this. So I'm just going to match up things that go together. Which pair do I know? Well, the 800 actually across from the 45. The 5 degrees inside the triangle is across from the wind. And the 130, the biggest one, is across from the plane. And all I'm going to do is pick 2 at a time to solve for. If I want to solve for the wind, I'll do these 2. I'm going to cross multiply. And then divide. And I think the wind should be, I get 98.61. And all it wants to know is the speed of these things. So just done. And I can do the same or a similar thing. I'm going to use this pair and this pair and find the plane. So r times the sine of 45 equals 800 sine 130. Do the exact same idea, divide with the sine 45. And r should be 866.18 kilometers per hour. Yeah, slightly different question this time because we're asking for the speeds, not the directions. Okay, one last one. Again, pause it, try it yourself, see what you can. Okay, our last one here. The plane with an airspeed of 1,000 kilometers an hour wishes to fly to a city that has a bearing of north 40 west. There's a wind blowing from north 25 east at a speed of 100 kilometers an hour. Okay, so what's going on here? We need a compass. An airspeed of 1,000 kilometers an hour wishes to fly to a city at the bearing of north 40 west. So it's actually aiming this way at 1,000 kilometers an hour. But the wind is going to blow it toward where it wants to end up at, which is actually this way. And that is north 40 west. I'm going to put the 40 across it in red. How is it going to end up there? Well, there's a wind that's pushing it. Probably made that a little bit long. The wind is blowing from north 25 east. North 25 east. So the wind is actually going this way. It's 25. So at the top here, if I add that to the top of my diagram, make this guy a little shorter so to make it look reasonable. It looks like north 25 east. I think that looks reasonable. That's my wind. This is my plane. It wants to end up here. That's where my city is. And the speed, oh, we got speed of 100 kilometers an hour, the wind. Okay, what direction should the plane head? So I need to figure out this angle right here. Wrong color. I need to figure out that angle right there. So it's going to be north somewhere less than 40, right? 40 minus whatever that x is. So how can I do that? Well, I got to find the C pattern in here. And whenever we have these things, there should be a C, and I think there's a C right there. So if I look at this corner of the C, it looks to me like it's 65, which means this angle is going to be 180 minus 65, or how about 115? That 115 is across from the 1,000. So I can say 115 across from 1,000, and I want my x, which is across from the wind. That's going 100, and we're going to do our partial cross multiply. Oops, let's just say 1,000. Sine x. We want x. We're going to take the inverse of this big massive stuff. And I got x, it's pretty small. I got 5.19. So for part A, which way should it head? Well, it wants to end up in north 40 west. I'm going to get pushed that direction, so I'm going to take my 40 minus my 5.19. That gives me 34.81. So I'm going to say it should head north 34.81 west. And it'll get pushed by the wind the rest of the way. What is the actual speed of the plane over the ground? So remember, it was flying the blue line at 1,000 kilometers an hour. Where does it end up? It ends up on the red line. That's a resultant. Okay, I can find that by matching up things that go together again. Another sine law question. So I still have this 115 and 1,000. I got to find the other pair that goes with r. In other words, the angle across from r. And the angle across from r would be this guy up here. To get that guy up there, what do I got to do? 180 minus the 115 from this corner minus the number we just figured out, 5.19 in this corner down here, gives you 59.81. So we're going to do the sine of 51.89. Oops, dyslexic there. 59.81. Just a cross multiplying question again. We're out of room here. Okay, we want r by itself, so we got to divide by sine 115. Sine 115, and r is, I got 953.72 kilometers per hour. I'm hoping you notice some themes there today. That C pattern is really helpful. We use it all the time to figure out the angles in between. Okay, kind of like we did forces yesterday. We're using the sine law and the cosine law. Just be careful when you're reading the words. Blowing from or blowing towards, that's usually the big tricks. Okay, a couple to try. If you're stuck, come see me, ask me some questions, we'll figure some stuff out.